Oh, you're speaking about the so
That's it?
Yes.
Yeah. And yeah. I'm sure I was gonna wait.
That's the one you were looking for?
Yeah, the stick. Okay. All right. Hello, everyone. Welcome back to the Python decal. We're going to get started for today. I'm going to basically do the first third of class today, and then Charlie's going to take it over. The goal this week is to just review basically all the foundational concepts of Python before we actually dive into tools that you can use for your final project and get to like the really fun and exciting part of coding. So today we're going to talk about I'm going to talk about mainly the final projects. Okay, so these are your general announcements. Homework 4 is due Wednesday, and then homework 5 was released today, and it is due next Wednesday. It's mainly just review, so mainly working on loops and lists and all that fun stuff. And then also there's some stuff in there to help you brainstorm for the final project. Okay, so let's get started. All right, so I'm just going to throw these all up on the board. But the goal of the final project is that you want to show us what you know and what you learned this semester. So we aren't a traditional class. We don't have quizzes, exams, finals, etc. We instead do a final project. And the goal is to, it's basically like your final because it's called a final project. But yeah, you're going to basically get up here during the last week of instruction. You'll talk for 1 to 3 minutes, which I know is not a lot of time. You're really going to have to figure out how to condense everything down to like 5 sentences because I will be sitting right there timing you and I will cut you off. Don't worry, it's only like 3 minutes. So you can basically memorize the whole thing if you want to do that, or you can completely wing it. We get both. But yeah, so you might be thinking, I have no idea what to do for the final project. I don't even know how to code really yet. I'm still super confused about the homework. It's totally fine. Basically, we give you an entire month just to brainstorm. So we're going to split this up into basically 2 different assignments. You have your month of writing your proposal, which is basically October, and then you have your month of working on your project, which is November. I know that falls right around when midterms are happening and finals. Like, it really sucks, but we don't have a better place to put it. But there are a lot of good ways out there to brainstorm what you want to start doing, and any instructor, you can go to any of their office hours. They're more than happy to point you to some great sources, some data you can look at. I'm more than happy to help you brainstorm. Yeah, so that's number 2. Number 3, you're now entering the part of coding. I haven't been here during many lectures, but I'm sure there's probably been a point where you've asked a question and someone's been like, oh, you should Google that. I don't know if that's happened, but it's a pretty common occurrence when we teach up here. And yeah, we don't know everything, and you're probably going to want to do stuff that none of us have ever coded before, and that's perfect. That's super awesome. But you're going to have to start looking into things yourself. If you're going to want to use, we will teach you how to use AstroPy, which is a tool for Python. But you might have to start doing some of your own research and looking up tools inside of it and functions you can use, etc. So yeah, dive into some new things that you can do with coding. That's really fun. Hone your research skills. So we're not ULab. We don't give you a huge research project that you get to work on for a whole year, but we do give you some initial work at it. So research involves asking questions, planning, messing up, making mistakes, and then starting all over again from the very beginning, and then asking another question and diving down rabbit holes. It's really a very complicated and broad process, and it can be very frustrating trying to figure out your final project, but it's very, very rewarding in the end, and it's something that you created. So yeah, you get to try testing out how to ask questions and answer them, and then practice your science communication skills. I think that's the number 1 most important thing that you should take out of this project. Well, besides the coding, because we're Python decal, but it's really good to practice communicating your work and your science to other people, especially your peers. That's basically what Charlie's going to be doing tomorrow at our undergraduate colloquia. But it's basically being able to explain really complex ideas very simply. It's actually a really hard thing to do. You might have gone to been in lecture and your professor's writing stuff on the board and you're like, I have no idea what's going on. very common occurrence. So that means they're not very good at their science communication. They could work on it a bit more. So that's something you're definitely going to practice when you stand up here, but you'll have to do it only in 1 to 3 minutes. So it's not a lot of time, but anyways, okay, moving on. I'm just kind of blabbing. All right, so what are the components of your final project? I kind of like thinking about it in 3 different categories. So you're going to basically code something, kind of expected with, like I said, the Python decal. And it needs to go inside of a GitHub repository. You spent the last month or so dealing with Git, all of its problems, adding, pushing, committing, all that stuff. And now you're going to basically, you have your own GitHub repository for homeworks, and you've been pulling from the course assignments repository, but now you have to make an entirely separate one just for your project. And this will actually go on our website, so it will be published. If you really don't want it out there, we can put it on private, but we'd still like when you turn in your final project, it is a GitHub repository, so we can actually see the code that you created. So that's the first component. The second component is your report. It's not a long report. This shouldn't be a huge thing on your plate. It's literally just like, this is what I did, and like, this is my project. Like, let's say you're studying black holes. You're like, I studied a black hole, and this is how I did it. You know, it's very short, 1 to 2 pages. There's some examples already on B courses if you want to take a look. So that's the second part. And then the third part is your presentation. Like I said, it's basically how you're going to show the instructors or us, besides we're also going to look at your code, and everyone else in the audience what you've been working on for the last 2 months. So those are the 3 parts. You have your code inside of a GitHub repository, you have your report, and then you have your presentation. All of these are due on December 1st. For everyone. It doesn't matter if you're presenting later in the week. It doesn't matter if you present earlier, if you somehow want to, but everything is due on the same day. So just keep that in mind. It helps us for grading and etc. All right, yeah, and think outside the box and be creative. It might seem really hard right now if you're like, I don't even know what to do yet, but we're really excited to see anything you come up with. Like I said, I mentioned it during like the first couple of classes, but our main 3 categories are analyzing data, or making a video game, or making a simulation or an animation. But you can go beyond that. Like if you have the time, you can make an app. I've never seen that before, but you don't have to. But I'm saying like you can do more broader things than anything I put up on this screen. Okay. Great. So where can you find examples of final projects? I always get this question. So I updated our website this summer, and I added our projects from the last spring semester. So you should be able to go in there. You won't be able to look at the code, but you'll be able to click through the different slideshows and basically see like what to expect, how long your slideshow should be, get some ideas. You can also mosey around to look at other years. But yeah, so great place if you want some inspiration. Okay, so timeline for your final projects. This looks kind of scary, but I just wanted to include, all of the information here. This is also, I'll give you the document later, but this is basically everything that needs to get done before December 1st. So this is today. We're talking about final projects. And then you have your first assignment, check-in number 1, due on October 22nd. So you basically have 23 days to work on this. It's a really short assignment. You're basically just like, it's like a milestone towards your proposal. You're basically saying like, this is what I've done so far. This is my topic or my field that I'm interested in. Like these are the tools I might want to use, etc. And then you have your proposal due, which I'll give you an example of that in a second, due on October 29th. And then you're going to get in-class feedback on November 10th. So all the instructors will split up all the proposals, we'll all read them, and then we will, if you show up, we will give you individual feedback and hopefully help you tighten and narrow your project ideas. Then you have your second check-in due November 24th. That's basically like, okay, I've almost completed my entire project. Here's just like the last few steps that I need to get done. And then you have an in-class work day, which is just the Monday before Thanksgiving. I don't want to put a lecture and I don't know, you might want to go home early, you totally should. So that'll just be an in-class work day. And then there's no class on that Wednesday. And then you have everything due before class on December 1st. So that is a hard deadline. In Python Decal, we don't have a lot of hard deadlines. I'm usually very flexible. But your proposal, so this date right here, October 29th, that is a hard deadline. If you do not turn it in, you will get a 0. So please turn it in. And then these are hard deadlines. So we don't have hard deadlines in this class except for these components. So just keep that in mind. Of course, if there's a complete emergency, reach out, but just know there's like 70 of you and we have to grade all of them. So just keep that in mind. Okay, moving on. Okay, what should you focus on? Yes, all right. So, like I just said, you have your first check-in due. It's already posted on B Courses. I recommend taking a look if you have your computers out. And then you also have your final project proposal. And then there will be no extensions because we want to give you feedback. Okay, let's see how many bullet points do I have? Okay. All right, so what is your proposal? Basically, like I said, it's a way to describe to us what you want to get done. You have almost an entire month to complete it, but it's essentially a place, like I said, to write your ideas down on a piece of paper, write out your plan of attack. In fancy science words, that's your methods section, and then determine what tools you want to use, also very methods, and then get feedback from the instructors. It's totally fine if you write your proposal and then you're like, oh, wait, I want to do something completely different. Totally fine. Happens all the time. Or you're like, oh, I wanted to like simulate the Big Bang. And then you get like 2 weeks into it. You're like, oh, that might have been too difficult. So totally fine. But this is just so you can get feedback from us. Okay. So what's next? All right. Yep. And then, so I'm just saying the same things over and over again, but those are the things you should focus on. All right. Okay. Okay. So I put up, I'll bring it up in a second and you'll hear me repeating a lot of information. But on your proposal, these are the key components that we want to see. So you want to have your title. Try to come up with like a fun title. I mean, you don't have to, but like at least a title for your project. Don't just name it Final Project. Your names. Oh yes, I'll mention this now. I'll give you a QR code and a few slides, but essentially, like I mentioned at the beginning of the semester, you can either work by yourself or in a pair. There cannot be triples, quadruples, etc. It's just you and potentially someone else. So just keep that in mind. And then a short description of what your project is, like a pitch. You've probably heard of an elevator pitch before, just like 1 or 2 sentences, like what is your goal, what is the description? And then basically, what's the general idea or what is a question you're trying to answer with your project? So let's say you want to study like, oh, like do main sequence stars in the Orion cluster follow this trend or whatever? I don't know. Or you're also welcome to like look at a paper and try to replicate what they did. That's also totally, that is science. It's peer review, so you're welcome to do that. Methods, how are you going to get it done? Resources, what you'll need. And then the expected results, if you're like, oh, I'm going to make a video game. This is what I expect to receive, or etc. And then a timeline. Basically, you'll see on the proposal, I basically did it week by week. But most generally, like, what are your steps for completing this project? Okay. And then, yeah, totally fine if it changes. That's research. That's science. So, yeah. Did you have some? Oh, okay. All right. Gonna keep going. So, next steps. Yeah. I'll go through this with you. So we. Oh yes.
Do we have homework during the week, so we're working on it?
Yeah. Sorry. Well, I mean, like we want to give you time. Well, like it's kind of hard to learn coding without doing problems. Like you'll hear that in all your math and physics classes. So we will give you problem sets to work on, but really they're geared to help you come up with a final project. So, like on one of them, I asked you to. This sounds very scary, but query a database, and that basically means you're going to go onto the internet, you're going to download some data, and then you're going to analyze it. And that might be what your final project is. So it's like to help you with steps like that. But yes, you will have homework. But remember, you only need a 70% to pass this class. Okay. Good. And then I will go through these. And then yes, please go to office hours. You'll hear me say it a lot, but if you have no idea what to do, if you want help brainstorming, if you want some guide or some like rails on like where you should go so you don't get like down into a rabbit hole, please go to office hours. Charlie's been teaching this class for 4 years, so they're very good at helping students, and they were ahead. And then I'm more than happy to help. Any instructor is willing to help, so just keep that in mind. And if you're lucky, maybe I'll help you code it. No promises, but James coded my entire project for me, so now I'm here, you know? So We're very nice, but I am busy, so you have to come early if you want me to help you. Okay, so yeah. All right. So please scan this QR code right now because we're talking about it. This is also an assignment on Gradescope, so if you already filled it out, thank you. I'll stay out of the way. This is requesting your partner. If you do not have a partner in mind, but you would like to be paired with someone, then you are more than welcome to fill it out and we'll pair you with someone. We'll release those on, I don't know when we'll tell you, but we'll tell you in like a week or so. So yeah, just take a minute and fill that out. Okay. All right, I'm gonna keep going. It's also on Gradescope if you need to click this link again. Okay. Okay, so sorry, Charlie. Okay, so this is B courses. So this is basically your final project description. You're welcome to listen while you fill out the little form. But essentially, this has all of the information of what we expect for your proposal and for your final projects. I'll maybe post one with more detail about exactly how to turn in your final project in like a month. But this has all the deadlines, and then I walk you through what to expect, what we expect, and then where should you begin? Like, how do you get started? Some common project types, the main components or assignments that you'll need to complete. And then your proposal. This is basically just what I talked about, but this is what we expect. It's kind of just like the manual for how to get this project done, etc. So you're welcome to take a look. Okay, that's the first resource. Second resource, this is your first check-in. Like I said, super short. It does count towards your final project grade. So if you don't turn this in, you will fail this class. Because like I said in the syllabus, you must turn in all final project assignments. That includes your project, your report, your presentation, and these assignments. It's super short. It should take you like 5 minutes. So just make sure you turn that in. Okay, so, and then next, I mean, I probably won't actually fail you if you don't turn it in. I'm just saying that to scare you, but please turn it in. Okay, I'm very nice. Okay, all right. Here is something I whipped up over the last week or so, but essentially, this is what we expect a proposal to look like. I might say a lot of words right now that you don't know what they mean. Totally fine. But this is an idea of a final project. So for this one, I decided to detect and model an exoplanet transit with TESS data. So TESS was a satellite that they launched up into space, and basically it just looks at stars for a really long time and it tries to find exoplanets. It was very successful, and they have a lot of data. So basically, I want to analyze the data. So I'm gonna get, where's my mouse? There it is. I'm gonna get basically a light curve that looks like this, and then I want to fit a model to it. This is called a transit light curve. You're welcome to Google this later, ask me about it. And this is the equation that I am most curious about. This is some background. Those are my methods for how I want to get the project done. And then this is very light on what I expect these sources to look like, but you should fill in with more information, but tools, data, expected results, and then I have a very lengthy timeline of all the things that I want to get done. So this is what we expect you to do and turn in about a month. So that should help you out. Help you out. And then this is a template that I posted. So you're all going to just download this, shove it into Google Docs, and then just type directly, and then just turn this in when you're done. So hopefully that helps you out. Okay, last thing, and then Charlie's going to take over. This is our website, and if you go to final projects, and then you go to spring, you can just scroll through all of them, and you can see past projects, and then if my clickers aren't broken, yep, you can like click through what they did, etc. And basically, this is what we expect you to produce in like a little over 2 months. So yeah, super cool. Okay, are there any questions? Yes.
On Gradescope, you gave us the Google Form link for the partner, but then there's no password at the end.
Okay, the password is light curve. How about that? I'll make an announcement about it, or I'll fix the Google form. Thank you though. Okay, are there any questions? Okay, I'm gonna turn it over to Charlie then for some review. Feel free to. All right, guys, let's get started. This is recording and we are getting started with regular class now. Is this light level in the room okay? Can we see this fine? Okay, cool. So as per usual with our warm-ups, please everyone lower your computers. Yeah, I understand wanting to use them. We do encourage you to Google things a lot, not during warm-ups. So here are our warm-up questions. As always, you're encouraged to chat with the person next to you. And I'll give you let's talk for 3 minutes about all of these questions. Thumbs up, middle down, is that enough time? Awesome sauce. And for those of you online, I'm going to pause the recording, but please take this time to pull out a piece of paper and try to go through these warm-up questions. Thank you for all talking. I hope some of it was about the warm-up questions. So, does anyone have an answer for number 1? Hey, no shame if you're wrong. Do you know how many times I've just been wrong? Yeah, go ahead.
I picked fruits 1-1. It's in my second position.
Great. Fruits 1-1. Any dissenting opinions? Speak now or forever hold your peace. All right, yeah, I would agree. What about number 2? How would you print banana, grape, and plum out of the same list? Go ahead.
I don't know if this is right, but it was like a for loop.
Mhm.
Like for I and fruits I1, print fruits I1.
Can I request something of you? Can I have you write that out on my little thing? Because I have a little, oh God. Because I cannot, you just said words and I'm not, not functioning on it. So just ignore that. And no, I'll bring this to you. Accept. Right. There's a back button. Huh. I think that, yeah, because banana, grape, and plum, banana, grape, and plum. I think that is a valid approach logically, but I think you've got some syntax issues. So we'll see on the next slide. Is that okay?
Yeah.
We can come back to it. Okay. Number 3, write a loop that prints every fruit in the list one at a time. Who else wants to use my little thing and write up there? Wasn't it fun?
Yeah.
It was fun. Yeah. Yeah, you already raised your hand. There's no going back.
Oh, so good.
Oh shit, hang on. All right, there we go.
哦，
你回来看看，说一下。还是在日常，是那个 AMG 吗？交一交。那如果想象到，
Can you explain your syntax here?
Sure, so, we're taking each list
Uh-huh.
from collection of lists,
Mhm.
and then, we're using I because we know prior, to the problem that, we only have 2 entries per list.
Uh-huh.
We're looking to basically have a range of numbers that is like basically like just 1, 2, and so for every list in that collection of lists, we're using I to print the first and the second value from this.
Great. I haven't seen that specific syntax with the comma in between. Is that something that you've used before? I mean, your logic is sound. I'm just wondering if this is something that you've seen done before, or if you're just looking at the logic. There's no shame either way.
I just kind of did a comma. I feel like we could do a and I in range 0 to 1 and then do the.
Mhm.
Well, like I didn't think about it that deeply when I was writing it out.
No, your logic is great. This is exactly the kind of logic. Does anyone have corrections for the syntax here? Again, great logic, no shame in this. This iterative thing with people is a great thing. Does anyone have, yeah.
I guess it need be neat and nitpick the no colon at the end of before for something.
Call it mean, nitpicky maybe, but I did ask for syntax correction, so. Yes, basically. Yeah, so. In general, we're doing nested for loops. That's where your logic is correct. But in terms of syntax, actually, I can just go to the next slide because Brianna has it all written out for us. So let's focus on specifically number 3, for sublists and fruits, for fruit and sublists. This is a very clean way of doing it. You don't have to do it like this. Remember, you guys have access to these slides, so don't worry about hurrying to answer. So you can do that, yes, but your syntax is going to look more like this. For fruit and fruits, colon, next line, for I in range 0, 1, although it'll be 0, 2 because range is non-inclusive, then print fruit I. That is a totally valid way of doing it. It's just a syntax thing that I'm nitpicking you to use a fantastic term. Now, let's go back to number 2. So Brianna has done the very brute force way of doing this without a for loop. And by brute force hard coding, I mean that you're not thinking about it in terms of replicability, right? You're just saying, okay, I know which fruits I want to print out. I know what my list looks like. Let's just index into the list. I think if I'm correct to let me do this. I think what you would have to do to make this work is for I in fruits actually, I think if you do for I in fruits, you don't even have to do fruits I1 because that will go through each sublist, right? And then you can print, then you can say print fruits. Sorry, did anyone see, so I'm gonna finish writing what I was about to write, but can anyone see the mistake I just made? Look at the index, look at how I'm indexing into this loop. No worries if you're not spotting it, I'm gonna give you a few more seconds of awkward silence. Okay, so for I in fruits, if I just printed I, would I print the index or would I print the sublists within the two-dimensional list called fruits? Index or sublist? We would print the sublist. You can't index into fruits with a sublist. So there are a couple of changes that you could make here. And I'm gonna do this in red. You could either do for I in range fruits, and then that turns it into you're iterating over the index, or sorry, not range fruits, it's range length of fruits. In range length of fruits. So you could either do it like that, or you could have for I in fruits, print I1. Print the first index of your sublist, which you've called I. Cool? Great. This is actually a fantastic little segue into our review session. So you guys, are we good writing this down? Okay, I'm gonna move on. But yeah, great job. Thank you to everyone who volunteered to offer up your dignity to the whole class. I salute you, and it was very impressive, and you all did great. So let's do the review session. You guys filled out a Google form, and you guys requested practice questions. By far the most, and I see why. It is legitimately impossible to learn how to code without doing practice problems. You can learn the theory all you want. I took this class, I did not master loops until I had spent a summer doing loop problems. Not because I'm just a nerd who likes to do for loops, which I kind of am, but because I had a reason to be doing for loops. If you don't get a reason to be doing for loops over the summer, what are you guys doing? You know? So let's start with some simpler loop questions. It says simple up there. Don't be fooled, for loops are not simple, but in the context of for loops, these are of the simpler ones. So the structure of this is going to be, again, I think we're gonna make it through just simpler loop questions. And then we'll leave harder loop questions, and then I forget what is next, but those for Wednesday, which is a continuation of this problem. So take 5-ish minutes to make an attempt on all of these. If you want, you can just start writing pseudocode, which is just logic, kind of how I was saying that the logic in the warm-up questions was great. There were just some syntax issues. Don't get hung up on syntax. Start thinking about logic, and we can clarify syntax as much as we need. Cool? 5 minutes. Talk.
Well, so.
And for those of you online, I'm going to pause the recording and please take a second to just work on these practice questions. one second. I heard a few conversations going on talking about this being a similar logic to a homework problem. Yes. So we're going to write a for loop to print every character in the string Python. Does anyone have a starting point for me? Do we want this in code or do we want this on my little paper thing? Code. Cool. Okay, can someone give me an idea of how to start this? Yeah, go ahead.
You start the for header with for I and then the range of the length of the string.
Oh my God. This is why I don't actually like VS Code that much. Because it keeps suggesting things like it knows what I want. It doesn't. Let's just start with the actual word we're talking about and call it Python. Is that the right? Is there anything else I need to add to this line? Great. Don't you love how VS Code adds a tab before your next line? That part is really nice. Okay, what's next? Do you want to keep talking or? Me too, don't worry.
And then the same string, Python, and then square brackets, and then just
Print Python, Jesus. Python of I. Cute. So do we think this is going to do what we want it to do? You are very confident in your own work, and I applaud you. I'm assuming it's because you did it. Great, yes, that's exactly what we're looking for. One thing I would love if you guys could start to think about is a way to turn this into a function. We did not tell you to turn it into a function, but as you start to code more, you'll want to start thinking about how to make this a little bit less hard-coded. So this is what I'm talking about when I say hard-coded. I'm writing the string Python that I care about each time I need to reference it. But what if I want to change that string? What if I want to change it? What if I want to print out every letter in Julia? Like, then I have to go through every instance of the word Python and replace it with the word Julia. I don't like doing that because I'm lazy, and so is every other coder. Okay, great. Now we're gonna turn the loop into a function. Oh, I did already tell you to do that, didn't I? Turn the loop into a function with the argument word. So, who's gonna tell me how to do this one? My fingers type what you tell me. Yeah.
Print on the third characters.
Parentheses word. Okay.
For I.
Let's stop that. Like this? Yeah, the colon. Do we think that this is going to work? Thumbs up, middle down. Okay. How do I call this? How do I say do what this function defines? Do you want to keep talking or do you want to let someone else do it? All right. How do I call this function? Yeah. What word should I do this for? Cherry. All right. I'm not going to ask where that one came from. All right. Will this work? Let's find out. There it is. Very nice job. Thank you, guys. Let's move on. I'm just gonna leave this uncommented for now. Okay, what would the word astronomy return? Feel spirit, I promise this isn't a trick question. Someone just say it. That's a fair point. Yeah. I bet if I typed this instead of astronomy, then it would return cherry. It just, yeah. I appreciate smartassery. I'm also certified smartass. It is 5 o'clock. I have to run. Please come tomorrow. Please come on Wednesday. Don't come tomorrow. We won't be here. And I will go through the answers to the next one.